Hello, and welcome to another bonus episode of the Food for Thought podcast. I'm your host, Erin Hallstrom. With me on the podcast today are Wayne Perry, Senior Technical Director at Kaiser Compressors, and Neil Meltretter, Technical Director at Kaiser Compressors. On today's episode, we're talking all about compressed air. We kick things off talking about all of the things to consider when deciding where to install your compressor. Both Wayne and Neil talk about the importance of ventilation, in particular how it impacts compressor performance. We also talk about the necessary clearance needed around compressed air equipment, as well as hearing about less than ideal compressor installs and how you too can avoid the same blunders. We cap things off talking about why you may want to consider a standalone enclosure for your compressor. Enjoy the episode! Welcome to the special bonus episode of the Food for Thought podcast. Let's dig right in. When planning a new plant or expanding an existing system, what are some of the considerations for where your compressor is installed?
Well, I think one of the prime considerations ought to be ventilation. You've got to have cooling air coming in. You've got to have a way to get that cooling air, once it's heated up, out of the compressor room or away from the compressor. Typically, insufficient cooling is going to wind up leading to higher operating temperatures on the compressor. It's also going to lead to more failures, breakdowns of the compressor. Oil is going to give out a little sooner than it normally would. If you've got really elevated temperatures in there, then it's also going to affect all of your air treatment equipment. You're going to wind up having a very difficult time getting the air dry again if you can't get it cooled back down. If you don't have a way to get cooling air in and out of the area where the compressors are, you might want to consider water cooling. That adds some cost and complexity to it, but it's a good way if you can't get good ventilation in the compressor room. If you're not 24/7, and even if your equipment can be offline long enough to get cold, you've got to be concerned if you're water cooled, because if you've got freezing temperatures in there, you need to make sure that all of that water cooling circuit stays warm. Neil, have you got anything to add?
Yeah, I think, man, that's the biggest issue I think that we ever see in a compressor room is ventilation, so bar none. So thanks, Wayne, for hitting those points pretty hard. I think the other thing you have to think about is the space. What are we going to put in whatever space that we have allotted? Is that space big enough? So that's for me a primary consideration. Also, what's the flow, pressure, and air quality? Wayne mentioned, well, you have this dryer or that dryer, you have to consider how much ventilation that dryer might need. So it's imperative to understand what the customer or the end-use requirement is, air quality, flow rate, and pressure, to figure out how many compressors do I have to have in this space, and is that space big enough? Also, power distribution. Is there enough power to run the equipment that we need in this particular location? So those are the other things that kind of bring it in. And then also, your other portion is your distribution piping as well. So, how far do you have to run to get to that main header and things like that.
I'm curious, how does ventilation impact compressor performance?
Well, Wayne made this question easy for me since we kind of hit that in question one, but the vast majority of compressors that are out there are air-cooled, and if you don't have enough cooling air, then the compressor can't maintain its operating temperature, so you're going to have the machine shutting down consistently. not only is that going to negatively affect your compressor performance, but it's also going to negatively affect your bottom line. Probably increase scrap rates, increase downtime, lost productivity costs are going to be high. You have those things, you're also going to have shorter mean time before failure. So, your service costs are going to increase as well. If you are running the compressors too hot, you'll have a higher amp draw as well as power consumption. So you're paying for that in multiple places. One thing that we see when we're out in the plant and you try to open the compressor room door, and either you can't pull it open, or it slams wide open. It's usually a negative pressure in the room. It can't bring in enough cooling air, so that means that the inlet pressure in the room is lower than the ambient. So you might have a compressor at sea level, but it's acting like it's at elevation, maybe even in Denver. So that compressor then has to work harder. The compression ratio is much higher, resulting in higher power consumptions, and the compressor that's working harder. So, those are the things that we see in regard to ventilation impacting compressor performance.
Yeah, something to remember out there is that it's actually the number of molecules that you get out into your system that actually does the work. It's the number of pounds of air, not pounds per square inch, but the actual weight or mass of the air that goes out. And if, as Neil says, you've got a negative pressure in the room, that means you're not getting as many molecules of air into the compressor as that compressor can handle, and that's going to reduce the amount of work that can be done out in the plant.
How much clearance is needed around compressed air equipment?
All the compressed air equipment is different, really, but certainly you need enough clearance around the compressor to be able to get in and do service on the compressor. You need enough clearance to be able to get equipment in. If you have to change out a heavy item like a motor or an air end or a cooler, where you may need a lift or a hoist or a forklift, get in there, you need to have enough room to be able to get that equipment in and service the compressors or the dryers. You also need to have enough so that the cooling air discharge from one piece of equipment isn't blowing directly on another piece of equipment and making the cooling air to that equipment any hotter than it needs to be. Remember, the rule of thumb is for every 20 degrees temperature rise, air can hold twice as much water vapor. So if you've got a compressor that should be discharging at 100 degrees Fahrenheit, and you're feeding it with hotter air, feeding it with 100-degree air, and now it's discharging at 120, that means you're going to have to double the size of the dryer to be able to get that air dry again, because that air is carrying twice as much moisture. Neil, do you have anything to add on that?
Yeah, I usually tell a dad joke here. I can fit around a lot of different things, whether it be in a car or in an unfinished space where all the the equipment is. But I'm not a very big guy, and like Wayne said, I mean, if you have to take an air end out or a motor out or a cooler out, just think about how many people are going to be required to maneuver in that little space, whether you need a hoist or not, or a lift. And then, also end of life. Compressors can last anywhere 10, 15, 20 years. We've even seen some 40 years. But when it's time for that machine to be replaced, how are you going to do it? So yeah, clearance, I can't stress enough. We're not asking for an IKEA location where you get space galore, but we're also asking for sufficient space that you can work and remove things. Also to consider safety codes, electrical codes as well. Those things are also very important. And then, where the equipment's placed, we talked about that in the first question, but, is it next to something that's going to be too hot or that's going to give off some kind of additional chemicals that may affect the compressor operation or performance over time? We've had compressors in various locations, which I think we'll talk about that later as well. But you have steam in the room or something like this, then that exacerbates everything else when it comes to your compressed air system. So keep those things in mind.
Yeah, I think the other thing you have to keep in mind is everybody's looking at arc flash protection, and you need to be able to have a lot of clearance around all of the electrical control panels, not just the ones on the compressors and dryers, but if you've got disconnects on the walls or fuse panels on the walls, you need to be sure the equipment is far enough away from those that you can safely work around that kind of equipment.
Well, for the record, dad jokes are always welcome here. I'm sure you both have seen some installs that were less than ideal. Can you talk about one or two of the worst you've seen?
Oh, gee. Yes, in 40-plus years of doing this, I have seen a lot of bad ones. I mean, the last question we had was about clearance around the compressor. And I remember getting called into a particular installation in Albuquerque, New Mexico, where they had installed large rotary screw compressor as they were building this building on campus at a university. And they called me and they said they were having trouble. The machine was overheating, they didn't seem to be getting the performance out of it. So they took me into where this was. We opened the man door, walked into the room where the compressor was, and you could barely fit between the compressor and the walls. And I'm looking around. It's an air-cooled compressor. There's no ventilation in the room. There was not even another door. I asked the people, I said, how did you get the compressor in here? And they said, well, we had the floor and everything done. We installed the compressor, and then we built these cinder block walls all around it and put a door.
Neil, in a previous food processing podcast last year, you discussed the idea of housing the compressors in a standalone enclosure outside of the plant. Does that help with some of these concerns? Can you briefly discuss that?
Yeah, I think it absolutely does. The last point that Wayne made about the telltale heart compressor, as I'll call it, where, we just put it in this location. It made sense for where we were going to need the air, and then we just walled it off. Moving the compressor outside of even the plant allows you to rethink the space requirement. So, if we have a location like a conveyor system where maybe it's a sorting facility, recycler, or even a trash facility, in a lot of cases, those machines get placed in the open space or even under a conveyor where you get debris, all kinds of things that may or may not be cleaned in regard to the coolers. So, then we have the over temperature issue we talked about kind of in the first place. You move it outside of the plant, it allows you to recreate the room, redesign the ventilation system, and make sure you have full power access. A lot of customers like it because it has really 2 points of connection, 1 point of connection for power, because then that power distribution panel feeds all the compressors, dryers, master controllers, etc., that are inside of an enclosed system. Then it has one location for piping, so it's necessarily a one-stop shop. That's a great selling feature, but it also allows customers to rethink their facility. Compressors, in a lot of cases, cover a valuable space in a facility, and so to rethink that space, to reuse that for production, could be a huge boon to a customer, layout-wise and flow-wise. That's fantastic. Safety and noise are another thing. Rotating equipment can be noisy, but servicing is also really a key feature. Now, plant personnel and service personnel, there's definitely interaction between the two. If you have a third party working on those things, they won't have to come through the plant. So a lot of food processors have proprietary protocol. I recall one of my good friends telling me, so I went into this facility and I had to be blindfolded, so I couldn't see anything that was going on in their process. And then they brought me to the compressor room. Well, if you have it outside the compressor room or outside the plant, it makes that access a lot easier for third-party service personnel as well. And with integration being a huge topic these days, you have this enclosure, you have a master controller, you tie right into that, you get all the data that you want. I'd say it's like sitting in the room, but it's even better because you get reports, how is the system running, you get alarms and messages. So that's really paramount, I think, for any plant engineers, plant managers, production managers these days.
Yeah, to Neil's point, we've had several customers that where we put in these enclosures or buildings outside of their plant that house the compressor room and then just pipe the air in. And they wanted to do that because they wanted to add to their production facility, add more production to their plant without having to build any additional facility. And you can monitor that, just as Neil said. You can put a master control that ties into every piece of equipment in this enclosure, and you can sit at your computer and monitor everything that's going on out there. To reiterate another point that Neil made, it's really great because the service people, your service providers, their technicians are not coming into the plant and disrupting the plant to do work on the equipment. It's just a benefit all around.
Well, Neil and Wayne, you compressed so much valuable information into this special bonus episode of the Food for Thought podcast. Thanks for joining me today.
For everyone listening to the Food for Thought podcast today, thank you for tuning in. You can find us on Apple Podcasts, Spotify, Stitcher, and just about everywhere you can listen to a podcast. Be sure to tune in next time as we talk more about the stories behind the headlines of the food and beverage industry. Take care. Have a great day.